Okay, first example, we have 70,072 divided by 19. Before we do our division, since we are now dividing with multi-digit divisors, it's kind of important for us to just have a good estimate before we start. So recall that whenever we estimate, we look at the largest place values in both the divisor and the dividend. That's basically just saying look at the number all the way to the left. So 19, would it make more sense to round that up to 20 or round all the way back down to 10? 20, because I'll put 9, it's 5 or more, I'm going to raise the score. So I can think of this as 20. I look at 70,000 and 72. Well, is that closer to 80,000 or is it closer to 70,000? It's much closer to 70,000. It's basically already 70,000 because there's nothing in the thousands place. There's nothing in the hundreds place. There's just a couple tens and a couple ones. It's really, really close to 70,000 actually. So that's what I'm going to write down. So I know I could think of this as a division problem kind of similar to what this is. I know that I could put the first number into the tent because it's first, it'll come first. And then I see zeros and zeros. I know that I'm basically dividing some power of 10 by another power of 10, so I can cancel the zeros out. I know whenever I'm saying divide powers of 10 by powers of 10, don't worry about that. If I see a zero in one part of a division problem and a zero at the end in the other part of the division problem, what can I do to them? Yeah, cancel them out. Why divide them if I don't have to? So now this question is basically, how many groups of 2 are in 7,000? Another way I can think about that is, what is half of 7? What number can I add together to equal 7? I know that if I take 2 groups of 3, yes, if I take 2 groups of 3, what number will I get? 6. If I take another half of one group, that's 3.5. So as Giselle said, if I took 3,500 plus 3,500, what number would I get? Yeah. 7,000. It's just 7,000. What number do I have here? Just like in our number talks, whenever we had an odd number and we had to take half of it, you just take one number away. So now I'm thinking of 6. What's half of 6? 3. And then add a 5 to the next place value. Half of 7 is 3 5/10. I can write the 3 and the 5 and then add my zeros. So my estimate, what is 70,072 divided by 19? I'm estimating it's going to be somewhere really close to 3,500. Okay, now who knows all the multiples of 19? Really? I'm impressed. Okay, so what's the strategy I can use for whenever I don't know my multiples? Yes? Multiplication tower, and that's exactly what this is asking to do. It's basically saying, hey, let's write out some multiples of 19, because whenever we're doing this problem, we're going to have to ask ourselves repeatedly, how many groups of 19 go into this? How many groups of 19 go into this? How many groups of 19 go into this? So wouldn't it just make sense to write out the groups of 19 before we begin? Okay. Well, I mean, let us do that. And remember, whenever we're making a multiplication tower, we write the divisor, 19. Okay. And if I add a group of 19 to this, what's my new sum going to be? 38. If I add another group of 19, what will it be? 57. Now at this point, I want you to stop and look. We're adding the same number over and over again. Let's see if we can see a pattern. Every time I add 19, let me do this in a different color. If I add 19 to 19, I say 9 plus 9. What is 9 plus 9?
18.
So I write my 8. And then I would have to regroup my 1, right? So what happened to the ones place? It decreased by 1. In my tens place, increased by 2. Here, my ones place decreased by 1. My tens place increased by. So using knowledge of this pattern, look at my ones place. I know it needs to go down by 1. So what's 7 minus 1? What is 5 plus 2? What is 6 minus 1? What is 7 plus 2? What is 5 minus 1? What is 9 plus 2? What is 4 minus 1? What is 11 plus 2? What is 3 minus 1? What is 13 plus 2? Okay, so did I have to actually multiply this out over and over and over again? Did I actually have to add? What did I do? I just looked at a pattern. I noticed that within the first 3, here was my pattern. The ones place, I took away 1. In my tens place, I increased by 2. If you can see patterns like that, you can quickly write out your multiplication towers. If you have your multiplication towers, you can quickly divide. You need to understand one strategy to build upon the other. If I walk around right now, who all has this written down? I hope it's on your paper. Okay, so now I need to find the exact answer using the algorithm. How many times will 19 go into 7? It will not. Okay, so now how many times will 19 go into 70? I don't know, so 1, 2, 3. Does McDonald's sell cheeseburgers? Division, multiplication, subtraction, check, bring down. So now I divided 70 by 19. Notice how I'm ignoring everything else. I'm not looking at this whole problem getting overwhelmed. I'm looking at the smallest problem possible. What is 7 divided by 19? 0. Okay. What is 70 divided by 19? 3. So now I have to multiply. What is 19 times 3? 57. Now I have to subtract. 57 minus is being subtracted from 70. So I know that I need to regroup. This becomes a 6. This becomes a 10. What is 10 minus 7? It is 3. And then what is 6 minus 5? 1. Okay. So now I'm asking myself, how many times, well, is 13 smaller than 19? That's my check. Now my bring down is my B. This 0 is going to be brought down. How many groups of 19 will divide into 130? Let's count. 1, 2, 3, 4, 5, 6, 7's too big. So the answer is going to be, so 19 divides into 130 6 times. That was my division. Does. Now McDonald's, multiply. 6 times 19 is 114. Can I take 4 away from 0? I need to regroup, right? So my 2 or my 3 over here becomes a 2. That becomes a 10. Now I have 10 minus 4. 2 minus 1. 1 minus 0. All right, I'm about to run out of time. So now this comes on down. Now I have a 7. How many times will 19 go into 160? 7. Let's decrease this 1, increase this by 2. So it looks like it'll go 1, 2, 3, 4, 5, 6, 7, 8, as you guys said.